Given the function g of x equals the greatest integer of x squared, answer the following questions. Before we do this, let's review the basic greatest integer function, also referred to as the floor function or step function, given by f of x equals the greatest integer of x. This function returns the greatest integer less than or equal to the input x. Notice for f of 1.1, f of 1.8, and f of 1.9, all the outputs are positive 1, because positive 1 is the greatest integer less than or equal to 1.1, 1.8, as well as 1.9. But then f of 2 returns the greatest integer less than or equal to 2, which is 2. Notice if we focus on this piece of the graph below, for all the x values from 1 to 1.9 repeating, the output is positive 1, but then as soon as x reaches positive 2, the output jumps to positive 2, and the function has discontinuity. Notice the step function has discontinuity at every integer input. This will be important for the second part of the given question. And now going back to the given question, again we have g of x equals the greatest integer of x squared. We want to determine the following function values. G of 0.5 is equal to the greatest integer of the square of 0.5. The square of 0.5 is 0.25. The function output is the greatest integer less than or equal to 0.25, which is 0. G of 5 halves equals the greatest integer of the square of 5 halves. The square of 5 halves is 25 fourths, which is 6.25. The output is the greatest integer less than or equal to 6.25, which is 6. G of the square root of 7 equals the greatest integer of the square root of 7. The square of the square root of 7 is 7, which returns the greatest integer less than or equal to 7, which is 7. G of 3 equals the greatest integer of the square of 3. The square of 3 is 9. The greatest integer less than or equal to 9 is 9. For the next part, for what values of x, for x greater than 0 and less than or equal to 2, is g of x discontinuous? Let's work on this on the next slide. To begin, the given floor function has discontinuity when x squared is an integer value, for the same reason why for the basic step function we have discontinuity when x is an integer value. This means we need to find the values of x when x is greater than 0 and less than or equal to 2 when x squared is an integer value. To help us do this, let's let z equal a non-negative integer. We know z must be non-negative because x is greater than 0, and therefore so is x squared. And since we know x squared must be an integer value, we'll set x squared equal to z, and if we solve for x, we would take the principal square root of both sides of the equation, again because we know x is going to be non-negative, giving us x equals the square root of z, where again z is a non-negative integer. So now we'll select non-negative integers for z to find all the x values when x is greater than 0 and less than or equal to 2. For example, let's start with z equals 0. So now we'll select non-negative integer values for z such that x is greater than 0 and less than or equal to 2. Notice x equals 0 is not in the interval, so if we try z equals 0, we get x equals 0, but this is not going to be one of our solutions because we're looking for x values greater than 0 and less than or equal to 2. So we'll go ahead and eliminate this as a solution, and now we'll try the next non-negative integer for z, which would be z equals 1, which gives us x equals 1, which is in the interval and will be one of our solutions. And now we'll try z equals 2, which gives us z equals the square root of 2. The square root of 2 is greater than 0 and less than 2. This is also a solution. And now we'll try the next integer, z equals 3. The square root of 3 is also in the interval, which is a solution. And now we'll try z equals 4. Z equals 4 gives us x equals the square root of 4, which is 2. And notice 2 is in the interval. 2 is a solution. If we try z equals 5, we get x equals the square root of 5, but that's greater than 2. It's not in the interval, and therefore it's not a solution. This indicates there are 4 values of x in the interval where g of x would have discontinuity. And we can go ahead and check these x values in the original function and see we do end up with the greatest integer of integer values, which is where the given function would have discontinuities. I hope you found this helpful.